Periodic law is of great importance when it comes to chemistry and analyzing properties of chemical elements and their compounds. Based on periodic law, we have periodicity of properties, or periodic recurrence of similar properties when we arrange chemical elements in order of their atomic numbers. In other words, similar elements and particular properties repeat at regular intervals of atomic number. For example, the chemical elements oxygen, fluorine, and neon with successive atomic numbers 8, 9, and 10 are respectively similar to the chemical elements sulfur, chlorine, and argon with successive atomic numbers 16, 17, and 18. Where elements of both these two sets are respectively similar to the chemical elements selenium, bromine, and krypton with successive atomic numbers 34, 35, and 36. So here, between similar elements, we have regular intervals of atomic numbers equal to 8 or 18. Periodic law and periodic table are very closely related to each other, as the first well-recognized proposal of both of them goes back to 1869 by the Russian chemist Dmitry Mendeleev, where many other scientists have also made great contributions to these concepts before or after him. The periodic table proposed by Mendeleev well exhibited periodicity of properties and periodic law for his era. As in its arrangement, properties of elements were important for Mendeleev, as periodic table has always been an important tool for chemists to illustrate periodicity of properties and periodic law. Mendeleev and scientists of his era were unaware of atomic number, but they paid attention to properties of elements well, and with the log from correlation between atomic number and atomic weight, they were able to propose initial periodic tables and periodic law, considering atomic weights instead of atomic numbers. One obvious illustration of periodic law by periodic table is the occurrence of similar elements in the vertical columns of the common form of the periodic table, numbered from 1 to 18, known as groups or families of the periodic table, such as group 1 or alkaline metals, group 2 or alkaline earth metals, and so on, where we have regular intervals of atomic numbers equal to 2, 8, 18, or 32 in groups. In addition, we have periodic trends, which are specific trends or patterns in properties of elements revealed in the periodic table across periods or along groups. Among commonly discussed periodic trends, we have general trends of increase of ionization energy, electron affinity, electron negativity, and decrease of atomic radii and metallic character across periods from left to right and along groups from bottom to top. For example, generally every period starts with an alkaline metal at group 1 as the most reactive metal of the period, and then as we go across period from left to right, the metallic character decreases while non-metallic behavior increases. So we see metals first, then metalloids, and then non-metals, with a halogen at group 17 as the most reactive non-metal of the period. And finally, period ends with a noble gas at group 18. Here, it is very important to consider that periodic trends are general trends which may have exceptions, sometimes more than a few ones. Periodic law and periodic trends are results or reflections of periodicity of properties or the recurring patterns in properties of elements, where the periodicity of properties itself is a result of the recurring pattern in electronic configurations of atoms, of elements, since any similarities or differences in properties of elements can ultimately be linked to their electronic configurations. Our modern theories, backed by innovative experiments, can well explain these recurring patterns thanks to theoretical or experimental contributions by many great scientists. Anyway, here we can see that when it comes to chemical elements and their properties, we have important recurring patterns which can be referred to or illustrated in different ways as periodicity of properties, periodic law, periodic table, and periodic trends, where all of them are ultimately linked to the recurring pattern in electronic configurations of atoms of chemical elements when listed in order of increasing atomic number. This is interesting, isn't it?